All right, hey everybody, Nick here. I wanted to make a little video and talk about the concept of pseudocode. And in most of my programming classes, I tend to stress heavily the importance of writing pseudocode before you begin writing actual code in whatever language you're working in, Python, C, whatever. But when I look back, I realize that for many of my students, they don't really know what I mean by an algorithm, and they generally don't know what I mean by pseudocode. And so, let me start by making this differentiation between algorithms and programs. And I'm going to make a claim here, just based on my own experience and opinion, that the real essence of being a good programmer is not about your ability to create programs. It's your ability to create algorithms. And in practice, we go from some goal. We want to create a game. We want to create a browser. We want to write a control system for some piece of hardware. We go from that goal to an algorithm. And this is the real challenge, right? Knowing what we know about computers, what are the steps we can take to perform some set of tasks. And once we have the algorithm, turning that into a program, this can be an almost mechanical process. The more you program, the better you know your language, the more mechanical this step becomes. But this is typically not where a lot of our effort goes. So this is very hard. This can be easy. And then when we've got our program and it's not working, we have to make a debug cycle. Our debugging is going back to this process of converting the algorithm to the program. Oh, I made a typo. Oh, I forgot to initialize this variable. Oh, my conditional statement is backwards, right? What we really don't want to do is have to change the algorithm. So this is what we really want to concentrate on as programmers. How do we go from what we want our program to do to coming up with an algorithm, a set of steps, right? So the algorithm is a set of steps. Do this, see if this is true, and do either this or that, and repeat this until this other thing happens. Converting the algorithm to the program, well, if you're writing Java, you do one set of steps. If you're writing assembly language, you do a different set of steps. But this process, you get better and better at this the more you do it. This is what we really need to learn first, though. Because we've got to have a good algorithm, an algorithm that will achieve our goal. We've got to have a good algorithm before we get a good program. If our algorithm's wrong, it doesn't matter how good we are at this step, our program's going to be wrong. So in fall, in 224, we're going to spend a lot of time just working on going from our goal to an algorithm. And we're not even going to get into actually converting this into a program up front. And so what tool do we use for concentrating on this part of the process? This is where we use pseudocode. And pseudocode is not your program, right? Pseudocode is a description of your algorithm. So when I was first playing around with programming, which was back in high school, there were no courses I could take, so I was just kind of like, trying different things and figuring them out. And one thing I discovered was that most of the creative work I had to do was figuring out what steps do I want to perform to achieve some goal, whether it's a prime number generator or, a battleship game or, whatever. It was trying to figure out this algorithm. And I had heard the term flowcharts. I'd read about it in books. I'd never really made flowcharts. But I started getting into a bit of a habit. So at lunchtime, I would walk out to Pudgy's Pizza. It was a nice little pizza joint right down the street from the school. And I would order my pizza and my soda, and I would sit down. And then I would grab a bunch of napkins, and I would start sketching out steps on these. And I called these creations Pudgy's napkin flowcharts. It's a term I used for years. And the idea of these Pudgy's napkin flowcharts was to describe in as much detail as I needed the algorithm that I was after. And you know, years later, I discovered this is called pseudocode. So let's look at pseudocode, and let's look at some examples. And the real challenge here is knowing what level of complexity we want in our code. So I'm going to pick on a sort of classic problem. I'm going to perturb it a little from the way we do this in our classes at Clark. We're going to have a three-way traffic intersection. We've got north, we've got south, and we've got west. And this is highest priority, and this is lowest priority. And at each lane we have red, green, and yellow lights. And it works like, you know, a traffic intersection would with these single lane roads. So exactly one car will have a green light. And if, for example, south has green and then a car comes to the north and north has higher priority than south, then the south light should turn yellow for a few seconds and then turn red, and north should turn green. And then if a car comes to the west, nothing happens because west is lowest priority. If another car comes to the south, nothing happens. But if north leaves and there's nothing to the south and there's a car to the west, north should go from green to yellow, wait a few seconds, and then turn red, and then west should turn green. So we do a version of this, different directions and priorities. But it's a nice, you know, concise problem. And we'd like to look at some pseudocode for doing this. And so let me show you first an example of pseudocode that is too high level, too sparse in the details, right? Now remember, our goal is to come up with a set of steps that achieve, in this case, you know, the implementation of a three-way traffic intersection. And we want to be able to go from this pseudocode, these steps, into an actual program pretty easily. So let me show you a first example of something that does not satisfy this, something which is not a good set of pseudocode. And that's this right here. And so our steps are initialize stuff. Check north. If car present, do yellow. Make light green. Do the same for south and west. Now, if I hand this description to an expert C programmer and I say, can you write me a C program to do this? They're going to laugh and say, no, I cannot do that, right? What does check north mean? What does do yellow mean? What does make light green? I thought we had 9 lights in here, right? Do the same for south and west. Do what same for south and west, right? This is a very first version of pseudocode, perhaps. It's like a rough draft. But it's like trying to write a novel, right? Let's say you want to make a novel for Indiana Jones, right? Your high-level description might be, you know, archaeologist finds ancient relic. Stuff happens, people fight, people betray each other, good wins out in the end, right? Okay, well, yeah, that's an outline, but you can't really go from that to shooting the scenes, right? That is not a script. And what we're after is a script. We're after a detailed set of instructions that tell us what is supposed to happen without worrying about the programming part. So this is way too high level. Now, let me show you a more detailed version of this, and I'm going to show you this in assembly language first, and then we'll look at it in C. This is an assembly language version of pseudocode, similar to what I see sometimes from students. And the problem here is that it's too low level, right? 7F into ADCON1, FF to port A, 0 to port B, bit test file and skip if set, port A, 0. If I handed this to somebody who knew nothing about programming, would they know what this traffic light is supposed to do? Absolutely not. This is riddled in low-level details. This is assembly language. And our goal is that, you know, this algorithm should describe how to accomplish whatever we're after. I should be able to show this to somebody who knows nothing about programming, and they should be able to understand the steps that I want applied. This does not do that. This is assembly language. This is pretty close to the finished program. This is what it might look like in C. right? C equals 1, P equals 2, while 1 if C equals 1, P equals 1, C equals 2, set lights PC, right? It looks a little more legible, but to somebody who doesn't know C, to somebody who's never written a computer program, this is meaningless, right? Because this is a program. This is way too far on this end of things. We want to be way up here. We want a description. All right, let me show you how you can make this a little better, but this still does not make it pseudocode. But in that assembly language example, for example, we could have things like car north, check south, south green, set south yellow, right? And this at least, for somebody who does know assembly language, gives you a little better idea what's going on. And in C, current green is 1, prior green is 2. If light has changed equals 1, prior green equals 1. This is getting closer, right? But we're still way too much on the programming side. And again, somebody who doesn't know what a computer program is or doesn't know what a computer is, this is going to be meaningless to them. So now let me show you an example of what I would consider to be good pseudocode for the traffic light controller. Step 1, initialize I/O, A to D settings, etc. Step 2, is there a car to the north? Yes. If north is not green, make all lanes red, set north green, and go back to 2. Step 3, if there's not a car to the north, then we'll say, is there a car to the south? If there is, if south is not green, make all the lanes red, set south to green, go back to step 2. Step 4, and this will happen, if there was not a car to the north and there's not a car to the south, but there's a car to the west. Yes. If west is not green, make all lanes red. Set west to green, go to 2. And then I would add one more step here, which is just go back to step 2. All right, so what is it about this that makes it more usable than this, right? And the idea is this is high level, right? Somebody who knows nothing about programming can look at this and they can start to make sense out of this. I'm going to somehow check to see if there's a car to the north. If there is, I'm going to see if north is green. If it's not, some other light is green, I'm going to make all the lanes red. And then I'm going to set north to green. And that's it. I'm going to go back and I'm going to do this again. And as long as there's a car to the north, north will be green, and it'll just hang out here. And then if north disappears, but there's a car to the south, and then I'll say, oh, south is not green. I'll make all the lanes red, which makes north red, and then I'll make south green and go back to step 2. So this is high-level code. This has nothing to do with whether I'm programming in C or assembly language or Python or something else, right? This is a high-level description. But if you are good at programming in assembly language, you can turn each of these things into a set of assembly language code pretty easily, right? How do I know if there's a car to the north? Well, I have to read a port, I have to use a bit mask, I have to do a bit test and skip or a branch of 0 or something, right? But in learning how to program in assembly language, what you're learning is how to take something like this and turn it into a bunch of assembly language statements. If I'm writing in Python and I want to set north green, well, I'm going to set a variable equal to something, or I'm going to call some function and pass it an argument. But being able to write Python statements that will do this for my particular setup, relatively straightforward. And if there is a problem in the end with my program, it's not this that I need to be thinking about, right? If I believe this algorithm is correct, I don't need to go back and reassess it. Wait a minute, what if there's a car to the south and the west? Is this going to work, right? You answer those questions here before you get to the level of this. Because debugging this is a nightmare. I don't want to go through this and figure out, am I handling the case where there's a car on the south and the north correctly? I want to be able to look at this and say, am I correctly setting north to green? Am I going back to the right place here? Am I correctly checking to see if there's a car to the south? Little steps, right? And the other thing is I'm modularizing. I've got this notion of make all lanes red, and I said this is below. So I have a second page of pseudocode for make all lanes red. And this simply says, if north is green, how do I make all lanes red? Make north yellow, sleep for 2 seconds, and then make north red. If south is green, how do I make all lanes red? Make south yellow, sleep for 2 seconds, make south red. And if west is green, how do I make all lanes red? Make west yellow, sleep for 2 seconds, make west red. I can code this in whatever language I'm working in, right? And believe that these are the steps. This is the pseudocode for this goal of making all lanes red. And then incorporate that into this pseudocode. One of the pieces of this algorithm is to make all lanes red. So this is modularization, and that's a topic of another video. But this is the idea of taking large tasks and breaking them into smaller tasks. And I can use these smaller tasks to accomplish my larger task without having all of this repeated here and here and here. All right, so that's an idea. Pseudocode should be number one, a complete description of how to accomplish your goal, written in a way, number two, that that somebody without any real knowledge of programming could still understand, and written in a way that, number three, as a programmer, you can translate these steps into actual steps of a program relatively easily. And number four, when you're working on that programming part, you do not need to go back and be thinking about what these details should be, right? All the questions of, well, how do I manage a 2-second delay? Well, you know, that's handled in here. That's handled when I'm making the lanes red. I make something yellow, sleep 2 seconds, make it north. I don't want to be writing this kind of stuff and somewhere in the middle say, okay, well, now I need to add a 2-second delay after I change yellow. How am I going to do that? I want that to be described in my pseudocode so that as a programmer, my entire task, once I've got my correct pseudocode, is simply translated into a program. And if something goes wrong, debug that translation, right? Not the algorithm itself. So that's another view of pseudocode. All right, thanks.